The next law we're going to address is something called Charles's law. And Charles's law has to deal, in this case, with volume and temperature, which means that our two constants that we're going to use, again, we're going to keep amount moles the same, but this time we're going to keep pressure the same. Okay? So pressure and moles are the same. All I'm looking at is the relationship between volume and temperature. So that means the amount of gas that's inside my imaginary sphere, that's going to be the same amount of mass. Okay? And the temperature, however, is going to be affected on this particular sphere. Okay? So as I add liquid nitrogen to the outside of the sphere, it cools things down. And what's going to happen there is as that cools down, the volume is going to decrease, all right, as my temperature decreases. That's I. Temperature decreases. When that happens, this is a direct relationship. Okay? Alternatively, if I increase the temperature, the volume of the sphere is also going to increase as well. All right? So volume will increase as I increase my temperature. Okay? And this is why in science we never heat a closed system. If you heat a closed system, it's going to explode. Go figure. Why? Because you're energizing the materials inside until a point where the container can't hold back. There's too much force, pressure on the inside, and that's going to blow your container up. Okay? So Charles's law, we are going to look at, and we're going to say, since this is a direct relationship, we can say that V is proportional to KT, okay? And as far as temperature goes, it's going to be direct, okay? So I'll write this over here. Charles's law, I'm going to call this Kc, excuse me. That's Charles's law, is proportional to Kc times T. There's one more law that we're going to address here. That comes up next.